All right, and then moving on to labs 2 and 3, when we looked at some more complicated functions using the Dobot, the magician robot. Lab 2, we started off by looking at image processing and feature matching. This is essentially when we started using the camera lens above the Dobot robot. And the first function we looked at was the fast match function. What this essentially does is it matches features based on the shapes and different characteristics of the object placed onto the camera lens. And it looks at this based on the previously uploaded templates onto the fast match function. And then we also use this point-to-point measurement function here, which essentially gives you the distance, the angle, and various different measurements between the two objects. We have a quick video here, which essentially shows we use the Penn State logo here for instance, and we actually ran this continuously. So as you can see, as soon as we move it, it switches and gives us all these different measurements, which is really nice. Next, what we looked at was the color extraction function, which also requires calibration. So essentially what calibration is whenever the robot arm is trying to pick something up, we need to coordinate the robot coordinates and the tool coordinates with the image coordinates. And we have a little image here which kind of demonstrates all the different coordinate systems. And this is important so the robot actually knows what it's picking up, and all the distances and angles are kind of correctly calculated. And yeah, essentially how the color extraction works is there's another function which is color extract. And in this function, you can input RGB values based on what you're looking for. And in this video, for instance, we tell the robot to only look for the red blocks. So as you can see, the robot kind of moves over, finds the red blocks itself, picks it up using the suction cup, and moves it out of way. So this is also a really important part for our final project. Next, we looked at the robot-to-robot interaction module, which we also call the handshake module. And basically all this did was it helps us communicate between two different robots. The flowchart kind of shows how one robot gives the input signal, and then the handshake module takes place, which involves basically a small circuit, a breadboard with kind of two resistors, an LED, some other components. And then eventually this gives the output signal to the second robot. We have a quick video here, which essentially shows, yeah, just picking up a block, putting it down in a kind of pre-decided location, and then you would send the signal. The LED would actually light up, which we can't see in this video, but the LED's purpose is to kind of show that the signal has been sent, and then, like you see, the second robot picks it up and kind of does whatever. And then finally, we looked at vision-guided robotics in our third lab as well, which is basically, this is very important again for our final project. And what this does is it's the logic to pick up a shape, correct its angle, and then drop it into the right shell template. So we have the flowchart here, which kind of shows we have two fast matches, which are each for first picking up the actual object, which in this case was these small rectangular shapes. And then the second fast match looks for its shell, which is the template, which you can see in the middle image. It's kind of picking out the centroid. And then we have two shell modules. So these shell modules are extremely important because essentially what this is, it's C++ code, which is correcting the angles. So what it does is it takes the angle difference between the actual template, the actual shape, and then it looks at the template may also sometimes be at an angle. So it calculates this difference, it corrects this and sends an output to the move point, which actually drops the shape into the template. So as the video is showing, it's going to correct its angle, drop it into the template, slightly off, but that's kind of good enough. And yeah, like I said, this is extremely important for the final project, which we will now talk about.
So the send code was actually pretty simple. So the logic that we used was to take a colored image, extract the colors, that way we could find the red pieces, use the blob tool to determine the centroid of all of those, and then take that black and white image that the blob tool exports, and then import that to the fast match with all the templates. Then using that, we'd be able to move the robot arm to those pieces, and then move them to the other robot, to which then we would send the signal for the other robot to pick them up and do what it needed to do. So as you can see, the video to our right is the robot actually performing the code that we writ, and then to the left is the code. You can see that the code pretty much follows the exact logic that we had described earlier. Um, and what we actually found was that by putting all four files into the fast match, it would run, and then if it didn't find the first one, it would immediately go to the second one, and then so on and so forth. So we bypassed being able to put branches in like a lot of other groups by just having this very simple code. And then on the bottom is our input output function that would send to the other robot to determine that we were done.
So our receive code logic was slightly simpler because we would already be given the correct pieces, or at least the correct color of the piece. So we just needed to take a black and white image. So the idea was take the black and white image, determine using fast matches which piece it was, then using the same image, determine which slot it needed to be in with branch logic, and then move the piece to that correct slot. So the picture to the left is our code for receiving. It would wait for an input signal from the send robot and then move towards completing the process. And what we actually did was we had the first fast match is to the first letter F in this case, and then the branch logic for the rest of those is that if the fast match finds a match, it follows it down. And if it doesn't, it goes to the next fast match, and then so on and so forth. And then because it's running iteratively, once we're done, we just wait for the next input signal. So here, the video shows that we already had the letters in place of the correct color. It identifies the F, picks up the F here, and then we use shell modules to determine the angle difference between the slot and the piece, so that way we could correctly rotate the piece matching whatever slot angle or whatever angle the piece had. We can see it very clearly here with the R, where it rotates in and then drops it off. We also place tape over the holes in the G and O piece, that way it would be easier for the robot to pick it up, as if we went from any other place there would be too much weight at any given point and the suction was not strong enough for the robot to fully pick it up. And then finally it grabs the O here, picks it up, and finally drops it off.